Excellent. Well, I've been excited about this. I am definitely a big time LANDFIRE supporter. So I wanted to give a shout out for the LinkedIn updates. I really appreciate them. I feel like the LANDFIRE team in Puma is on there a lot, and I do pay attention to those. So anyway, thanks for that. And then I will just say that my history with LANDFIRE goes way back. So Roger Ottmar is on the call, and he and I worked within the fire and environmental research applications team of the Forest Service. I was on the University of Washington side, he was Forest Service, and we developed the fuel characteristics classification system, which is quite a mouthful. And as we were doing that, we were trying to think about a way to map wildland fuel beds across the United States. And so we did partner with LANDFIRE early to create an FCCS fuel bed layer. So we're going to get into it, and I'll just say that for those of you who have worked with wildland fuels in LANDFIRE, there are a lot of different layers. Obviously, there's canopy layers, and then there's fire behavior fuel model layers. This is another approach to characterizing and mapping fuels. So FCCS basically takes an approach of trying to estimate all the fuels that would burn in a wildland fuel fire event, a prescribed fire, wildfire, cultural burn from basically the ground up. So it goes from forest organic soils, the duff layer, into litter, fine and coarse wood, herbs, shrubs, and canopy fuels. And so we have an accounting of the fuels that can burn in a wildland fire event. And so FCCS is particularly useful for assessments of how well did fuel treatments work? Did you reduce some of the fuels that could be hazardous fuels? And then also, especially for smoke. So what is FCCS? It's basically just an accounting system of the fuels, as I described, and it can be useful for carbon and biomass assessments because basically it's accounting for all of the above ground biomass in a site. But it also has equations that were developed way back when to basically move from the Rothermel fire spread model that relies on fire behavior fuel models to more realistic fuels in the surface fuel bed. So those would include litter, fine wood, herbs, and shrubs. And so we do have a surface fire behavior module within FCCS that can be really useful when you're looking at fuel treatments and if you've reduced fuels enough to affect fire behavior. It hasn't really moved into operational fire modeling, nor do we have a spatial FCCS at this point. I don't think we ever will. I'm going to end this presentation by talking about next generation fire modeling, and I think that that's a pretty exciting move, and I think FCCS has a role to play in that. The other model that's joined at the hip with FCCS is Consume. So Consume basically takes all those fuels that can potentially burn in a wildland fire event and then estimates fuel consumption based on day of burn inputs, and importantly, predicts fuel consumption and total emissions of PM 2.5, or if you were really interested in greenhouse gas emissions, you can do that with Consume as well. Another model that's really useful, and I'm pretty agnostic about which model works well for people, is the first order fire effects model. And you can certainly use FCCS fuel beds and then calculate inputs to FOFM and then run FOFM instead of Consume or in a model inner comparison. We've done that, definitely. And then really importantly, FCCS fuel beds can be mapped using LANDFIRE. If you were interested in looking at a prescribed burn unit and the potential total smoke emissions from these fuel beds within a burn unit, you can do that pretty easily with LANDFIRE. We'll get into some of the specifics about how you might want to customize some of those fuels in a little bit, but I think that this suite of functionality is where FCCS really operates. And some people don't even really know they're working with FCCS because they might be using Bluesky Playground, and in the background are FCCS fuel beds. So this workflow was developed by my colleague, Gina Kova, and I just wanted to talk through this briefly because I've got an example coming up that makes use of it. So oftentimes we're using LANDFIRE to estimate a fire perimeter. We might even use burn severity pixels to estimate how that fire burned, low, moderate, high, or unburned pixels. And then we use the LANDFIRE layer to estimate the pre-burn fuel characteristics. Consume, as I already mentioned, estimates the consumption and emissions for that fire event. So it's the total emissions. And then Bluesky Playground is really great at smoke dispersion. So as you can see, we've got some scenarios here that I'll get into in just a little bit where you can make use of fuel treatment scenarios or disturbances on these fuel beds. Consume really relies on day of burn scenarios. And then if you are moving into Bluesky, you really need to have your terrain and meteorology inputs for that event too, to estimate the dispersion. So here's just a screen capture of what FCCS kind of looks like now. We used to have a standalone desktop application, but it failed on government computers and it got old. So my colleagues, Paige Eagle and Brian Dry, have done a really nice job on building a web tool that everyone can use just because it's a available link. I've got this open up in my browser, and so we can explore this during the office hours. What we've really done here is allow people to select a fuel bed and customize it if they really have a need for better fuels that are more specific to their site. So an example is that you might have a prescribed burn unit in a grassland or a shrubland or a forest. FCCS fuel beds are not going to be perfect for that prescribed burn. You often need to open up the fuel bed and change some of the attributes of it to match your site before you estimate consumption and emissions or work on fire behavior estimates. So another feature of LANDFIRE is that it tries to stay up to date, and there's going to be a lot of cool innovations in this coming up, especially with LiDAR and different remote sensing products that can help LANDFIRE products stay up to date with disturbances or management history. Right now, in the background, our team helped out with developing a scripting process so that whatever fuel beds are mapped within LANDFIRE can be updated based on some major disturbances. So, for instance, if you have fire records from monitoring trends in burn severity or another approach, you can use the low, moderate, and high severity classification of burns to then update fuel beds to represent that. So I'm showing this here. FCCS field beds are then assigned an additional code. So you might have a fuel bed 52, which represents Douglas fir and Grand fir and ponderosa pine forest. And if that fuel bed 52 had been burned in a low severity fire and was really recent, like immediately following that, it would be assigned a code 111 to represent that type of disturbance, and the fuels would be adjusted to represent a really low severity underburn that reduced surface fuels but didn't really touch the canopy very much. And then all the way to you can represent a high severity fire again at 3 different time steps. These are basically 1 would be immediate, 2 is around 2 to 5 years post fire, and then 3 is about 5 to 10 years post fire. It would be great to refine this further, but that's what we have right now. So the major disturbances are fire, mechanical thinning, and prescribed burning is number 2. Mechanical thinning and some sort of just like chipping or mastication, leaving those fuels on site, and insect and disease in Windthrow. So another feature, this is kind of a boring but important feature, is that crosswalks that we have in LANDFIRE are the best that we could possibly do at the time. And I know that we're going to talk about how for your site, you're not really finding that the LANDFIRE mapped fuel bed at your 30-meter pixel or for your prescribed burn unit is a perfect fit. I think that we're going to have a lot of fun, and it's going to take some work over time to make use of AI, machine learning to do a better job with these crosswalks. But right now I wanted to let you know that for each geographic area, here we've got the Pacific Northwest, as well as I think it's the Rockies too, is in the Northwest. We have different map zones within LANDFIRE, and based on the map zone and the existing vegetation type fuel classification here, we have provided a crosswalk to a fuel bed. So this crosswalk is pretty generic, and we've always meant it to be a starting place for managers to do a better job with site-specific information. So you can see here that we have different map zones of the Snake River Plain down to the North Cascades. And here I've given you three different types of forest. So we've got a dry music mixed conifer forest, actually four, silver fir, western hemlock, grand fir forest, and then we have a shrubland. Actually, that's the fourth. And here the fuel beds are all the same. We are doing some work right now with the LANDFIRE team to adjust by map zone, but a lot more work is needed to make sure that we're not just assigning a blanket fuel bed across a really large region when we could fine tune them by map zone. Okay, moving on. This is where I'm going to start moving through some tools that make use of FCCS. And the first one that felt really important to mention is Bluesky. So I think many of you have heard about Bluesky or benefited from Bluesky because, much like me, you've been checking the smoke forecasts and wondering how the smoke's going to clear and when you're going to have better air. And so I wanted to just quickly mention that Bluesky framework provides a lot of air resources support for our entire nation. We're so lucky to have that. It's a U.S. Forest Service product and really important to continue maintaining. Some while ago, Bluesky switched to making use of the LANDFIRE fuel bed layer for 30-meter pixel fuels throughout the nation. So that's been a huge refinement here. You can see here that I've got a screen capture of Bluesky Playground. You can go back to the 1 kilometer fuels layer, or you could switch to 30-meter fuels. If you're using Bluesky and want to really zoom in on a wildland fire, either active wildfire or a prescribed fire, 30-meter resolution will be a little more up to date because it's making use of LANDFIRE. So what Bluesky really does is have this base map as you're clicking an area or uploading a shapefile of your particular zone of interest. You're selecting fuel beds. You don't know that you are. They just have a lookup table of the calculated fuel loadings or biomass available to burn. And then Bluesky asks for more questions here. I think I've got them here on fuels. Do you want to customize those fuels? You can actually do that within this really easy to use user interface. You can adjust the fuel moisture for that day of burn, environmental inputs, and then also it's pretty important to look at these consumption defaults. So if you know that you're working with a prescribed burn that's going to be kind of spotty, you might want to adjust how much of the shrub layer is actually burned. Piles generally burn like 90%, so that's pretty fair. But importantly, if you're working with an underburn and you're interested in using Bluesky, you might not anticipate any canopy consumption. So that would be a really important one to adjust. Consume doesn't do a good job on crown fire predictions. You kind of have to tell it what you're expecting or what happened in a wildfire. So from here, Bluesky will use consume to calculate total emissions for that fire event or day of burn, and then it will move into high split modeling for dispersion modeling. So I know I'm going kind of quickly, but I have all these tabs open on my computer, so I want to make sure that we have time after this to explore as you guys have questions. So what if you made use of LANDFIRE and pulled up some fuel beds of interest for a particular prescribed burn? Some of them might actually have that code I introduced. So it could have fuel bed 52, which we were looking for at the Bluesky Playground. But when you pull up the fuel beds and you have this little map of your 30-meter pixels with assigned fuel bed names, some of them might actually be disturbance fuel beds because that area might have had a prescribed fire within the last 2 to 5 years. In this case, you would want to actually open up fuel bed 52 in FFT and then actually say which fuel bed that you have. We will be adjusting this user interface over time. Right now, this is the way that you can look up disturbance fuel beds. I kind of like it because if people are trying to adjust a fuel bed, they can say what sort of disturbance they are trying to represent. But I would ideally like to have a drop down of all of the LANDFIRE disturbance fuel beds so you could just open those up in this system. So that's kind of getting into the weeds, but basically I wanted to let you know that our FFT Online does support disturbance fuel beds, and it's a great thing to take advantage of if you're trying to customize to a site that had a recent disturbance. All right, I'm going to move into just a project that's being led by Gina Kova with some support from the Forest Service on smoke trade-offs. And I thought that this set of slides was really helpful in showing how we're making use of some LANDFIRE layers. So here, Gina has this map of burn severity for wildfire in 2021, Snyder Springs fire in eastern Washington state. And so here we've got unburned or very low showing up in blue, low severity in green, moderate severity in kind of this yellow orange, and high severity in red. It's really helpful because then we can kind of use those burn severities as inputs to consume to estimate how much consumption would happen. So for instance, for a high severity area, we made some assumptions about how much canopy would consume in a high severity event compared to a low severity event. And then from that, we have mapped fuel beds from LANDFIRE in the background, and we can use consume to predict total emissions. This always looks like black lung disease to me right here. Snyder Springs is full of fuels, or was prior to this event, and the high severity areas are really showing up as really high PM 2.5 emissions, as you could imagine, because there's a lot of canopy consumption in those areas, whereas the unburned are showing up as 0 to, negligible amounts of PM 2.5. The available fuels in the backdrop are so important. And so here we have a map of the pre-fire vegetation conditions coming from LANDFIRE. And most of the fuel beds are this grand fire Douglas fir forest type that just have a tremendous amount of course, canopy fuels. It's dense forest, but also a lot of wood. This is the orange and quite a bit of ground fuel. So what we mean by that is the duff layer. And so this fuel bed packs a punch and probably is really representative of this pre-fire condition because it was fire excluded, pretty dense forest that had a lot of fuel accumulated. In areas that actually are purple, this is kind of the lower elevation, drier forests. The fuel beds just are much lighter in terms of their fuel loadings. And so they don't pack as much of a punch. This is definitely also the case for recently thinned and prescribed burn units. There would just be a lot less available fuel for the wildfire. So here's just showing the total emissions in kilograms per hectare between these two fuel beds. So the mapping from LANDFIRE is really important. And again, I can't emphasize enough that it's good to kind of look at the suggested fuel beds and make some adjustments if you think they're wrong. So here we also were able to make use of the consumption and emissions estimates from Consume to look at predicted emissions under a wildfire scenario, again, making use of the burn severity mapping compared to what might have happened if we were able to burn all of this in a spring prescribed burn. So spring prescribed burn wouldn't necessarily burn all of the duff layer or the coarse wood, and certainly wouldn't burn tree crowns. So emissions are much less. Fall prescribed burning still has quite a bit of fuel. So this is where we can imagine after a dry summer in eastern Washington, the organic soil layer, that duff layer, and the coarse wood are available to burn. So we estimate a lot more emissions under that scenario. So kind of rapid fire, but I wanted to give you a sense for how we're making use of LANDFIRE regularly in our work.
Quick question, Susan. Is that 2.5 kilograms per acre of PM 2.5?
So it's total kilograms.
Total kilograms. Okay.
Yeah. And that's a really good question. I'm glad you asked it, Megan, because these don't relate to AQI at all. We didn't really know how to categorize total PM 2.5 to be meaningful. So we just did a color ramp of that.
Gotcha.
Yeah. So I wanted to say one more thing I forgot, which is that we really do want to start pairing some of these emissions trade-off work with Bluesky because I think it would be really helpful for us to not just look at total emissions, but also look at ventilation and wind direction and think through how these different scenarios really affect communities downwind of these potential fire events, whether it's a wildfire or a prescribed fire. So to just take a few minutes to talk about some exciting next steps for FCCS. And again, this very much relates to LANDFIRE. I've been involved in a CERTIP, so Department of Defense funded project on 3D fuel mapping. And a lot of that has been hard work to try to estimate fuels in three-dimension cubes. And we've kind of catapulted to some pretty cool next steps. So I think many of you have probably heard about, quote, next generation fire and smoke models. One that's really being evaluated right now for operational use is QuickFire. Here, I'm just going to show you a quick video of where we were able to make use of LANDFIRE fuel beds and input them into blocky Minecraft type fuels and then run quick fire through those three-dimensional fuels. And so I wanted to talk a little bit about how we're making use of LANDFIRE and kind of what some steps are. And before I do, I've got to move my face. So okay, so here in the background of this quickfire run is actually the LANDFIRE fuels layer at a 30-meter resolution. We have a new tool called Fuelscraft, and I'm going to show you a couple of interfaces that are completely under development right now and love some feedback. We're working on ways to interact with LANDFIRE fuel beds, customize them, then pass them through a framework called the Fastfuels framework that is designed to be this superhighway of importing fuels into Fastfuels and then exporting quickfire inputs. So, and being able to run quickfire. And so this process is not streamlined yet, but I think we're really getting towards that point, and it's pretty exciting to be part of. So Fastfuels, very quickly, I'm happy to share this PowerPoint and the links can be accessed here, but it was really designed to integrate a lot of different inputs, whether it was like tree approximate objects from LiDAR for trees or making use of tree map to better ways to characterize surface fuels. All of that then being packaged up into voxelized, so volumetric pixels of fuels for quickfire runs. And I want to mention that Fastfuels is also really interested in providing inputs to even finer scale modeling that might be used for research, such as the fire dynamic simulator or fire tech. So I don't have a lot of time for this, and I wanted to just quickly say that this is one of our test examples of Fuelscraft. And so Fuelscraft is supposed to sound a little bit like Minecraft. And what we're doing here is circling, like you can use a shapefile, importing a shapefile, or draw a polygon on a map to represent your potential burn unit. We're representing, like we need to say whether we're in the Western United States or Southern United States. So there's a UTM map zone. And then we're also supplying an API key to access Fastfuels. And so with that, we're actually calling on Fastfuels here to give us information about the trees. So Fastfuels already has a way to map fuels, canopy fuels using tree map, or actually a fusion method that makes use of airborne LiDAR and better tree approximate objects. So within this tool, we can bring in the canopy fuel layer. We can actually edit that if we want to with our own better approximation of tree approximate objects. And then what I'm showing here is that for surface fuels, and this is really our contribution to Fastfuels, is that we're now allowing users to get a LANDFIRE raster layer that gives us fuel beds that are mapped for that area. Here we, again, this is on purpose, showing that most of this area is actually fuel bed 52. with a few kind of like bare ground ones, that's the FCCS 0 and a couple other stray fuel beds. And so here, what I would want to do next is go in within the Fuelscraft interface and start adjusting fuel beds. I took this from a different presentation. So here we're actually in the southeast with a longleaf pine forest. And if I were a site specific manager that had local information, or I went into the field with this application on my tablet, I could actually adjust the percent cover of the shrub layer. Talk about a spatial pattern, how much of that shrub layer was dead versus live biomass, and adjust the heights. If you knew something about the biomass, you could adjust the loading, and then also inform whether there's quite a bit of pine needle drape on top of that shrub layer or not. The herb layer is really similar here, where we've got an adjustment for how much grass cover there might be. Is the grass fully green or is it cured? That's where the percent live comes in, height, and again, loading. And another thing that I wanted to mention is that this application is pretty easy to adjust the species. So FCCS allows that. And in this rendition of Fuelscraft, which again is under active development, you can actually change the species to be very specific. Really matters for fire behavior. Some species are pretty neutral if they're deciduous and thin-leaved, and others are pretty volatile. So if you can imagine like saw palmetto or gallberry in the southeast, those would be species that you definitely want to customize. Here's another really cool application, and I'm getting close to my 30 minutes, so I wanted to end soon. We're also working on some Python scripting right now to go from a LiDAR-based point clouds, whether you have high resolution airborne LiDAR, it's important that it would be high resolution, or ground-based terrestrial LiDAR point clouds. Those can really help out with the understory fuel mapping. And then we can actually then bring in that information about what is actually the measured height layer of shrubs and where are shrubs not, and do we have kind of a tall shrub layer versus a short shrub layer. All that can come from LiDAR measurements, as long as you have a pretty open canopy if you're using airborne LiDAR, or if you have gridded fuel points from terrestrial LiDAR. Those can then come in and adjust FCCS fuel beds, which then can give you a species composition for that area and other information that might be useful to draw from the fuel beds, but you're actually customizing with actual measurements from the point clouds. So once again, this is a little bit blurry here, but this is just another under construction interface where we're bringing up candidate fuel beds. This one's a slash pine plantation that has had a prescribed fire in the last 2 to 5 years. And then you're further adjusting the surface fuels. Those then can go right into Fastfuels through this interface and provide quickfire inputs, which is exactly what we did for providing that example in quickfire. I'm going to end with just a cool set of graphics on this. I think this is where we're really headed, and it's exciting to me to think through ways where we could start customizing fuel beds with high resolution imagery. Here we have the trees segmented, and you'll see that the understory is also segmented too, for here into basically taking off the trees, taking off the boles, and then doing an understory height model that can be classified into small trees, shrubs, and then even lower surface fuels. So, wow, we're really catapulting into a next way of working with fuels. But I don't think that LANDFIRE fuel beds are going away anytime soon, because they do provide a template of fuel kind of composition that you might want to use in addition to this. So we can talk about that if you're interested in the office hour time. This is showing something really similar. I probably didn't need to include this one, but this is just showing another forest and our process of segmenting those trees and then removing the trees and the boles. This is a process that Hannah Redford did for her dissertation, cleaning up the understory and then providing classification of it. So probably didn't need that redundancy, but I just think these images are really cool. So with that, I'm going to, right on the money, stop at 30 minutes. Happy to share this PowerPoint. Everything's shareable. And here's just my contact information.
Thanks so much. Man, that was super interesting. I have a question about the visualization you just showed. What size, what's the scale of that?
Yes. So this one's what we called kind of like we did do gridded terrestrial laser scanning with a Regal unit, and then we fused those point clouds. So this is about 100 meters by 100 meters. So
Okay.
pretty small, but this method can be used with airborne LiDAR at much broader spatial scales, like a kilometer by a kilometer is something we've tested.
Wow.
The airborne LiDAR misses more, and would really require you to have an open forest to be able to have some points hitting that lower shrub layer. So terrestrial LiDAR is much better. So yeah.
Great. All right. Who has questions? We have about 50 people on the call, so feel free to just come off mute. If we get too many questions at once, I'll ask y'all to raise your hand, but please don't be shy.
Yeah, and I basically got Bluesky up, I have FFT up, and then I have these kind of in construction Fuelscraft apps up on my browser. And so we don't have to stay on the PowerPoint. We can go explore if you guys want to.
Cool. Well, that's a lot of options. So I'm sure there's folks
Mhm.
out there that would love to explore those. Let's see. Leland, go ahead.
Aha.
And feel free to introduce yourself so we know where you're from.
Hi, I'm Lee Tornay. I'm with the Air Resources Board, and I've played around with Blue Sky Playground a lot and fuels and the emissions estimation that comes from those fuels, of course. And I just wanted to note that in the latest Blue Sky Playground interface, there is the option to choose the 30-meter fuels,
Yes.
and I think that has a lot of potential in many places to be way better instead of the sort of 1 kilometer scale. Fusion, you have, if you're really interested in a particular spot in a particular burn unit, I think you're a lot more likely to get something realistic as a starting point from that 30-meter, as at least from what I've seen so far. Just wanted to note that.
Absolutely.
Yeah.
I'm glad that you mentioned that. So I chose the 1 kilometer fuels because it gave me the fuel bed I wanted for this demo, but I would definitely recommend that people make use of the 30-meter fuel there. It will definitely be a lot more up to date. And we'll continue working on it. I'm not satisfied with the LANDFIRE FCCS crosswalk, and Lee and I have been in communication about that. Yeah.
Thanks, Lee. I have a question about the Fuelscraft.
Mhm.
My kids play a lot of Minecraft, so I was immediately thinking about Minecraft when you showed that. Does Fuelscraft grab the most recent Landfire data using that raster option? And are you using the API option?
Yeah.
Or okay, cool.
Yeah, so that's pretty exciting, and again, I wanted to mention that you can see it, but in the top of my screen that this says not secure. We're paying for Amazon Web Services right now. We could certainly pay more to get a certificate, and then this would be a link that we could share with everyone. Right now, because we're in so much just testing and development, the API key I'm not actually supposed to be sharing.
Mhm.
I thought that was actually going to be
Whoops, no one's
hidden.
looking.
Don't look at that. But anyway, so basically the API key is supposed to just be for people that have asked Fastfuels for permission to use the tool, and they'll eclipse that one and have a new key. It's basically just to make sure that people are not like flooding these sites maliciously.
Right.
So, yeah, and then when we go get Landfire Raster, this takes a few minutes. So basically, the domain is specified, and then we're calling on Landfire API. So,
All right, who has other questions?
I'm tempted. If there are not any other questions and yet people want to hang on, what I was going to suggest is for me to demo the FFT a little bit just so that people get a sense for what fuel beds are. On purpose, I didn't actually include that in a PowerPoint because it gets a little bit boring. So I might suggest that, Megan, and then if
Yeah.
people want to ask for something different, we can.
Yeah, I think that's a great
Okay.
idea. People can
Okay.
also put your questions in the chat window too if things come up. So feel
Okay.
free. Yeah, thanks.
Um, so I've just got to, there's so many screens going on right now. I'm going to stop share there and then get onto my website. Excellent. So you should be seeing FFT, and I do want to apologize. I know that some people who are on their laptops, this is going to be really small text, and I'm going to put on my reading glasses. So, okay. Is that looking okay to you, Megan?
Yep, I can see it just fine.
Awesome.
And I put that link to the FFT online in the chat. So if anybody wants to follow along, feel
Perfect.
free.
Okay, sounds great. So what FCCS was designed to do is basically allow people to look at our library of 460 fuel beds. Most of them have been mapped into the LANDFIRE FCCS layer. And so these are the base fuel beds. And if we wanted to, we could click on this ecoregion map and look at a particular region and what fuel beds we have for them. I try not to be just specific to the Northwest where we study, so I'm going to go to the Southeast and let you know that we actually have 154 fuel beds that were developed to be relevant to the Southeastern United States. Again, that's kind of a big area. You know, we're on the eastern seaboard down through Florida and into Texas even. And so not every fuel bed is going to be specific to your site. And then if we wanted to, we could also look at vegetation form. Certainly need to update these graphics, but if we were particularly interested in mixed forest types, we could then hone it down to more of like, these are forests that have a mix of pine and oak or other hardwood species. So that would be a way to kind of start honing in. We could even go to cover types, and each time we're using these search variables, you're getting to a smaller list, actually. But the cover types didn't look like they went to a smaller list. Sorry. I might be wrong on that one. Those are looking like a lot of them. Well, maybe. I'm just surprised by some of these, but I think, yeah, it is a smaller list of cover types. So another thing that I like to do is if I'm really particularly interested in a species, so if I wanted to look at a particular pine species here, I could go to Pinus Tata for loblolly pine, and that would give you all of your loblolly pines. You don't have to go with tree species. You might want to be interested in gallberry, and so you could actually look at that one instead and find out where you have a species of gallberry. We should have more than that. I think that when I did that search, it first went to loblolly and then gallberry. But yeah, there's ways to actually search for a species of interest and then find the field bed for that. So I'm going to go back to the southeast. And then what I was thinking we might do is just choose a couple fuel beds that might be of interest to view. So we've got a pitch pine, scrub oak forest, loblolly, short pine forest, and then we'll do two different longleaf pines, one with prescribed fire and one with fire exclusion. Did I get the other one? I did not. Okay, so here what we can do is read through a pretty detailed description of what this fuel bed is representing. And so our intention with these reference fuel beds was really to be broadly representative. A lot of these are more like you can find young fuel beds, but a lot of them more in the mature forest area just to kind of represent that. And then change agents really are important. You know, if you've had a recent wildfire, then you're going to get to a younger forest example. So I'm going to just scroll down here and show you really what a fuel bed is all about. So the canopy fuels have trees, dead trees, snags, and ladder fuels. And if we're looking at the trees, basically what we have here is a cover, height to live crown, a density and diameter of the trees along with species. And so these are not that hard to open up if we wanted to, but I wanted to mention that right now we can't customize any of these because we're just viewing. If I wanted to customize the first field bed, which is 107, or I could just customize this one, I can add a copy to edit of this particular field bed 165. And I'm doing that on purpose because then we can move here and edit species. And then you can see that you don't just have the scientific name, there's also a common name, and you can adjust the relative cover of your overstory if you want. So all of this should be kind of like something that if you want to start using FFT, you can just kind of explore. But I did want to mention that if you want to look at species, you do need to start editing one of the field beds. Okay, there's an optional mid-story. Not all field beds have 3 layers to a canopy. These particular field beds that I opened do. And then there's understory, which generally represents really small trees, the seedlings and saplings in the understory. Snags are basically red snags, so ones that still have foliage, all the way to really highly decomposed, rotten snags without any branches and probably broken tops. Shrubs and herbs, I kind of showed you in Fuelscraft how we interact with this. This is FFT's version where we have the species. Again, if we wanted to look at the species here, we can look that this 165 has wax myrtle, swamp TT, and then pepper bush. But a manager could come in here and think like, well, I really don't just have 10% shrub cover. I actually have more like 50% shrub cover. So they could adjust that. Here we've got height in feet. Maybe their shrubs are shorter. So even though this is a lot of information, as people start making use of field beds and know which ones that they're going to work with regularly, it's actually really great to go in and customize them to be better fit for potentially a prescribed burn unit that you wanted to adjust. Herbs are similar, where you have a percent cover, a height, live amount of biomass, and then you do have to put in a loading, which is hard for people. And so this is where actually having a lot of FCCS field beds as references help. So you can kind of look at what we have in some field beds and say like, well, I have a similar percent cover of 10%. So I'm going to go with a low loading of herbs. Actually, I have a really high percent cover in similar species, so I'm going to go to a higher loading. So the reference field beds can really help with some of those tricky inputs. You'll notice that there's 2 layers. That doesn't have to be retained. Like if you felt like you only had one shrub layer and you really didn't have a second one, you can click off the second shrub layer and it just goes away. And so I do recommend that for beginning users. Like if you are interested in creating custom field beds for prescribed burning, go ahead and simplify them. If you feel like you just want to deal with one shrub layer and one herb layer, that's totally fine. Really quickly, downed wood is characterized in sound versus rotten wood and different size classes. So these are time lag classes, and we have definitions of their diameters. And again, species, you could probably use your overstory trees as a good estimate of your species composition for them. But these are important to estimate the density and therefore loading on the fuels. Stumps, sometimes stumps are a really big deal. For smoke in the southeast, you might want to look at the lighter pitchy stumps because they can burn for a very long time. And then piles. Pile burning is really, so common in a lot of areas. And so here we actually have an ability to, I think I'm not going to get into this right now, but there's a way to work with the pile calculator, which is a really cool tool, but I'm going to stop there and say, let me know if you want to start working with piles and I can show you how. And then litter, super important for fire behavior and smoke. We support Alaska fuel beds, so ground lichen and moss are very important up there. And then finally, I made a big deal about ground fuels and duff layers. These pack a punch for smoke, and we have that integrated as well. So I'm going to stop there, but just kind of wanted to let you know that this would be a way that you would be able to interact with fuel beds, really easy to run results. Here we just have some default scenarios about dry fuels, low wind speed, flat ground. You can go ahead and get outputs, and FCCS is pretty fast in the background along with consume. And so it just shows up on the same spreadsheet. So you've got your inputs up above, and then you've got your outputs down below.
It's incredible. I'd love to know if anybody on the call has used this tool, and if so, like what's their experience been like? And who manages this? Your lab manages this, or?
With funding from the Forest Service, as you can see, I'm highlighting Forest Service right now in LANDFIRE. So right now we've had really generous support from the Pacific Northwest Research Station, and this tool needs to be shopped around. So we just got it done. It's really ready to use. I'm so proud of our developers, but I'm starting to do some webinars on it. And so I don't imagine that a lot of people have used this tool, and we
Okay.
will have more training materials. We have a very good help system right here for documentation. I'm going to give a shout out to Page Eagle. This is pretty incredible. There is an ability to do just command line. If you have a lot of field beds from LANDFIRE, you can run them through command line and not work with this interface. So lots of ways to work with you. We're friendly too. And so as people want to use this tool, happy to support. So
Wow. I didn't realize it was sort of hot off the presses, so I feel lucky that we've been able to have you
I
on.
was excited to meet with you, and I was hoping there might be a question on this one, but given that people were happy to just have me present whatever, this was definitely what I wanted to present. So
It's exciting.
yeah,
Well, we'll make sure that we link to this in the YouTube description
great.
so folks can have that link easy to get to. I'm going to launch the evaluation poll really quick and go ahead and minimize it on your screen, Susan.
Oh yeah.
Are there any other questions before we sign off for the day? I feel like maybe everybody's just probably eating their lunch and listening, and that's great too. So
That's
we
fine.
really
Yeah.
I do have a question.
awesome. Go for it.
Thanks. I'm Joanna Nelson. I'm the principal of Land Sea Science in Central Coastal California. And Susan, thank you so much for this presentation. You and I have met at AFE conferences.
It's really good to see you. Yeah.
Thank you. I'm curious. I know this is about wildland fire and prescribed fire or past fire. And I'm just curious if there are any integrations that you know of, if, with past wildfire information and then management in prescribed fire, is there a way to do this model, use the tools you've showed us and show any decreased risk to urban areas? Like, here's what we're doing with fire or what happened to us with fire, and this is how it affects our risk for urban.
Yeah, two things. So one is that for really basic, I think you can still see my screen here. For very basic fire behavior, you can use, especially FCCS. I'm not sure why it's showing me in a weird form here. Here we go. So FCCS does predict potential for surface fire and crown fire, and I'd be happy to follow up with you on this, Joanna, but especially for communication with the public, if you were working with these fuel beds and wanted to share with the public, we have a fire excluded woodland or forest, and we've actually then done a treatment. You can develop fuel beds to represent both of those conditions. And FCCS is kind of ready made for then describing how different fuel beds have different predicted rates of spread and flame lengths. Sometimes the rates of spread go up with treatments just because you might have a flashy litter or grass dominated understory, but the flame lengths are much less. Another thing that I love to use this tool with is actually showing the source of the heat release. So the reaction intensity is a fancy word for how much energy is stored in these different surface fuel layers and where your problem is. So fuel bed 166 has a lot of shrubs, and that's where a lot of the energy is coming from. In some of the fuel beds that you might work with in Central California, it could be coming from a lot of grassland or a lot of accumulated vine wood. So anyway, I feel like these can be really helpful for speaking with people about the wildland urban interface and hazard. I really am also just like fingers and toes crossed about quick fire moving into even more realistic fuels. And we're not there yet, but I feel like in the next 5 years, there's going to be an ability to really make use of LiDAR based fuel mapping and then moving into assessment of fire risk with frankly better models.
Thank you so much.
This is Roger Otmar.
Hi, Roger.
Hi. And I'm emeritus scientist with the PNW PSW research station at this point. And Susan, this was a great presentation. Thank you so much. And Susan has really been the mastermind behind the fuel and fire tools and the FCCS. And I really appreciate it and very well done. I do have one question. Are you still there?
Yes, I am. And
Okay,
I'm going to say that
because
I learned from the
the
best, Roger. So
yeah,
thank you.
well, the internet has been cutting me off and on throughout this. But the question I have is with the LiDAR, it's really interesting and along with putting together 3D fuels. But how would you take the LiDAR information and actually convert that to litter and a duff depth, which is so important when it comes to smoke and fire effects?
Oh, I'm so glad you asked that question. So LiDAR does a really good job of what it can sense and measure well. It can't sense and measure litter depth and duff depth at all. Like litter, it can get coverage, but Roger, this is where FCCS fuel beds might be really helpful, where they would give an approximate litter depth as well as what might be underneath that litter. LiDAR is not going to solve everything. It really gives us where fuels are in three-dimensional space, but not even what they are. And so that's why we're recommending a merger with the LANDFIRE fuel beds and a lot of expert opinion.